Yesterday, actually, we have started studying about this particular point where we studied about the ionization constant of weak base. So let us revise the same today, and then we shall move forward. Ionization constant of a weak base. Dear students, if we have a weak base with us, we should study its ionization constant. The ionization of a base, suppose we have a base whose name is, or its formula is MOH, which dissociate to gives us M plus and OH minus. We can even write the same equation as MOH, which is added to water. That will give us the M plus or and OH minus, and this H2O will remain like H2O only. So that is why here we do not generally write this MOH. Like the water, we do not write it because there is no meaning writing it, because there are already OH minus present, and this OH minus, when they are added to water, they are just undergo the process of ionization or dissociation, and we get OH minus. So this is how, my dear students, we can understand that. You can even understand why when it comes to acid, we generally write, suppose if we have an acid, my dear students, MH, then we would have written water, so that we can write it as a M minus and H3O plus this way. But here it is not possible, and that is why we avoid writing water. But we just, to show the presence of water, my dear students, we just write this aqueous. So when we write aqueous, my dear students, it simply means that the water is present and all this reaction taking place into the water. I hope it is clear now. So for this equilibrium, my dear students, we can write equilibrium constant. And when we write the equilibrium constant, actually we write the equilibrium constant Kb, which is the product of the concentration of the products of reaction divided by the concentration of the reactants. And this constant, what we write it here as a Kb, we call it as the dissociation constant or ionization constant for our base, and that is why we put the sign B after K, and thus we call it Kb, my dear students. So this Kb is nothing but your ionization constant for base or dissociation constant for base. This is how we write it, and this is how we understand it, my dear students. Now, suppose if the initial concentration is C, my dear students, and that is how we can say that when we have the initial concentration C, and if alpha is the degree of dissociation, as we studied in case of the dissociation or ionization of acid, my dear students, we can write the initial concentration for this equation, which is C mole per liter, and as there are no reactants available at that time, so we write it 0 and 0 there. Now we understand the change. So when we understand the change, the concentration of reactant decreases, and that is why we put minus sign before it and we write C alpha. The concentration of products increases as the reaction move forward, and that is why we put plus sign on it, and then we write C alpha and C alpha. So at equilibrium, we can make sum of both of this to write the final concentration at equilibrium. So C minus C alpha, here 0 plus C alpha, that is C alpha, and here 0 plus C alpha, that is C alpha. By taking the equilibrium concentration from C minus C alpha, if we take C common, we get C into 1 minus alpha, here C alpha and C alpha. So you can see that the concentration of MOH, which is a base, is C into 1 minus alpha, whereas the concentration of M plus is C alpha and concentration of OH minus is C alpha. So by putting these values, C alpha into C alpha divided by C into 1 minus alpha, we can say that C divided by C is equal to 1, and we have C into alpha square divided by 1 minus alpha. So for Kb, we can write Kb is equal to C alpha square divided by 1 minus alpha. Now, see, please remember that if we take this is not that it is compulsory, but for calculation purpose, if we take, so please remember that we ourselves take this, that 1 is quite greater than the alpha, because this alpha is degree of dissociation for a particular base, and therefore we can write 1 minus alpha is approximately is equal to 1. So if you write Kb for 1 minus alpha, if you write 1 minus alpha is approximately is equal to 1, we write Kb is equal to C alpha square divided by 1, and thus we can find out the final equation, that Kb is equal to C alpha square, or alpha square is equal to Kb divided by C, and therefore alpha is equal to square root of Kb plus C. We can even put plus or minus sign here when we take the square root both the sides. So these are the two equations which are going to be very important for us to be studied. So by using this equation, we can find out the value of Kb if value of Kb is not given, but the value of alpha or degree of dissociation is given, and the value of initial concentration is given. But if the value of Kb is given and if the value of initial concentration is given, then we can find out the value of degree of dissociation for a particular or a given base. So this is how, my dear students, we study about this. Now we can understand it by using some idea. See, many organic compounds like amines are weak bases. Amines are derivatives of ammonia in which one or more hydrogen atoms are replaced by the another group. Please remember, we want to study about the amines. You are not actually taught about amines in the 10th standard. So here I would like to tell you, see, we have alcohols. So these alcohols are like CH3OH or CH2OH. So this portion is repeating. Instead of that, we will write it as ROH, where R is the alkyl group. This is what we call it alcohol. Same way, my dear students, when it comes to amine, we may have various amines like CH3NH2, we may have CH3CH2NH2, or we can even have NH3. So what happens, this ammonia, when you replace one of the hydrogen with CH3 or CH3NH2, it becomes amines. So what is amines? Amines are the weak bases. They are bases because this nitrogen possesses the lone pair, and as the presence of the lone pair, my dear students, this amines behaves like a base. So amines are weak bases. Amines are derivatives of ammonia. Derivatives of ammonia means you replace one of the hydrogen of our ammonia with CH3. So suppose if you write it CH3 here, it becomes CH3NH2, and this is how it becomes the amines. As ammonia is a base, my dear students, here these amines are also weak bases, and amines have the derivatives of ammonia in which one or more hydrogen atoms are replaced by another group. Another group means it may be CH3, it may be CH3CH2, or it may be something else. You can even think of these amines in some different manner, my dear students, that suppose in ammonia, if we have RNH2, suppose another hydrogen is also replaced, then we can write it RNHR dash. If a third hydrogen is also replaced, we can write RN R dash R double dash. And if all the three groups are same R, then we can write R2NH or R2NH, or we can write R3N. So these all are amines where nitrogen is having the lone pair on it, and that is why this lone, due to the presence of this lone pair, all the amines are weak bases, and they are the derivatives of ammonia. And in these amines, one or more hydrogen atoms are replaced by the another group. Another group may be R, it may be R dash, it may be R double dash, or you can say it may be CH3, it may be CH3, CH2. It may be sometimes C6H5, which is benzene. So you can even have the amine which is having benzene and NH2. This is what it is known as aniline, which is also an amine. So this is how, my dear students, you understand about amines. I hope it is clear to you. Dear students, have you understood about the amines? Any doubt in this?
No, sir.
Okay. So this is how you study about the amines. Now this, an important thing you need to remember about amine is, these amines are actually the derivatives of ammonia, and as they are derivatives of the ammonia, they have lone pair on nitrogen, and due to the presence of the lone pair, my dear students, these amines have, or these amines behaves as a weak base. So you can see that there are various amines we can study, like methylamine, where your R is CS3. So we can study about the methylamine. We can have codeine, guanine, and nicotine. These are the various amines found into the nature. You might have studied about the nicotine, which is found into the tobacco. These codeine and quinine are also found into the various substances. They are all known as alkaloids. You will study about them in detail later. All these amines behaves as a very weak basis due to their very small Kb. Their value for Kb is very small, and that is why they behave like a weak basis. Now ammonia produces OH minus in aqueous solution. So if you add ammonia into water, it produces OH minus, and that is why this, due to the presence of the OH minus, it is basic in nature. So you can understand the basic character. Ammonia produces OH minus OH minus ions into the aqueous solution. The pH scale of hydrogen ion is extended to get pKb. So my dear students, we can even have the new formula which is known as pKb. If we put the minus logarithm of the value of Kb, which is known as the ionization or dissociation constant of base, we can have the value of pKb. As the concentration of H minus, if we write the, or if we take negative logarithm of H plus, we will write it as a pH. Same way, if we take the negative logarithm of the Kb, we will write it as a pKb. So please remember that we have pKb also. So apart from the Kb value, my dear students, we can have the another value of pKb, and please remember it well, my dear students, that more is the value of the pKb, weak is the base. Please remember that more is the value of the pKb, weak is the base. So the strength of base, strength of base is inversely proportional to the pKb value. So if the pKb value is greater, the strength is going to be lower. If pKb value is lower, the strength of base is going to be greater. So pKb value or strength of base is inversely proportional to the pKb value, and if pKb value is more, the strength of base is lower. If pKb value is less, the strength of base is more. So this is how we study about the Aditya Tiwari. Okay, so this is how we study about the strength of the base. Now, my dear students, we want to study about the next question so that we can understand it well. The pH of 0.004 molar hydrazine solution is 9.7. Calculates its ionization constant Kb, and even we need to calculate the pKb. So let us study or let us solve this problem. Here in the question it is written that we have the solution of hydrazine. My dear students, hydrazine is this kind of compound, NH2, NH2. This compound is known as hydrazine. So when this hydrazine is added to water, you can see that we have the reaction. When this hydrogen is added to water, it takes the H plus from this water and produces NH2, NH3 plus, and it produces OH minus ions, which shows the basic character. So we can find out pH is equal to minus log of H plus, or H plus is equal to minus H plus is equal to anti-log of pH. The anti-log of pH. This is minus pH. These are the formulas that we can use and we can find out the answer for this question. Let us move forward and understand how we can solve this problem. So my dear students, we are given the value of pH, H plus concentration is equal to antilog of pH. We are already given the value of pH. So we put the value of pH as a 9.7, and that is what it is, the antilog of 9.7. Now for 9.7, my dear students, we can write 10 minus 0.3. So this for 9.7 is equal to 9.7. So for this 9.7 we can write 10 minus 0.3, and thus we just put the value of 9.3 as it is minus, so we'll write minus 10 plus 0.3, we'll get minus 9.7. So for 9.7 we'll write minus 10 plus 0.3, that is what we write it for 9.7. So antilog of minus 10 plus 0.3. Now antilog of A plus B, antilog of A plus B is equal to, my dear students, antilog of A plus, multiplied by, not plus, multiplied by antilog of B. So the same I have written here, that antilog of minus 10 multiplied by antilog of 0.3. Antilog of minus 10 is equal to 10 to the power minus 10. I have already told you, once again I am repeating, but please understand, this is what I am going to repeat it last time. Antilog of 10 to the power x is equal to x. Please remember, antilog of 10 to the power x is equal to x. So if you have antilog of 10 to the power minus, I have again made it mistake. Antilog of x, my dear students, antilog of x is equal to 10 to the power x. Please understand, antilog of x is equal to 10 to the power x. So antilog of minus x will give you 10 to the power minus x. If you antilog of minus 5, you will get the answer 10 to the power minus 5. So this is what we do it. And antilog of minus 10 is equal to 10 to the power minus 10. Same way, antilog of 0.3 is nothing but your 10 to the power 0.3. But to understand, we have a table which we call it as a log table, and thus antilog of 0.3 from the log table we can get this value 1.99, and ultimately we can find the value for our H plus concentration, and we came to know that this H plus concentration that we have is equal to 1.99 into 10 to the power minus 10, which is approximately equal to 2 into 10 to the power minus 10. Now I have taken 2 into 10 to the power minus 10 for just the purpose of doing the calculation easy. Now we are all aware that the ionic product Kw is the concentration of H plus multiplied by the concentration of OH minus, and the value for Kw is 10 to the power minus 14, and therefore if we put the value for concentration of H plus, that is 2 into 10 to the power minus 10 multiplied by the concentration of OH minus, is equal to 10 to the power minus 14. And therefore, my dear students, the OH minus concentration is equal to 1 into 10 to the power minus 14 divided by 2 into 10 to the power minus 10. This 10 to the power minus 10. So this power, if it goes up into the denominator, it changes its value and it turns to be plus. So if you have x to the power n divided by x to the power n, this simply gives us x to the power m minus n, and this is how you study it. So when you do it, my dear students, this 1 by 2 will give us the value 0.5. So it is 0.5 into 10 to the power minus 14 plus 10, which ultimately gives us the concentration of OH minus is equal to 0.5 into 10 to the power minus 4. So now we have the concentration of OH minus. We have already seen that the initial concentration of hydrogen was given as 0.004 molar. It was given into the question. Now when it dissociates or it ionizes, the initial concentration of product is 0. When we understand the change, you will find out that the change is minus C alpha for the reactant, and the product is plus C alpha plus C alpha. So by adding this values, we find out the concentration at equilibrium. So at equilibrium we have the concentration 0.004 minus C alpha, and this concentration for product is C alpha and C alpha. Now, my dear students, we have the OH minus concentration, which is equal to C alpha. We are already aware that the concentration of OH minus here is nothing but your C alpha, my dear students. So the concentration of OH minus is C alpha. So concentration of OH minus is C alpha, and that is what we have seen, that the concentration of OH minus is 0.5 into 10 to the power minus 14. You can see here the concentration of OH minus is equal to 0.5 into 10 to the power minus 4. So we put this value, and thus we are already aware that the C, which was the initial concentration, it was given 0.004 mole per liter. So instead of C, we put 0.004 mole per liter minus C alpha is equal to. Now, if we look into the concentration of our NH2 at equilibrium, it is 0.04 minus C alpha. So for 0.04 minus C alpha, we can write 0.04 minus 0.5 into 10 to the power minus 4, because the value of C alpha is 0.54 into 10 to the power minus 4. So by doing this calculation, now if you look into this 0.04 is nothing but your 4 into 10 to the power 4 into 10 to the power minus 3, and here it is 0.5 into 10 to the power minus 4. So approximately, my dear students, we can say that this value is quite greater than 0.5 into 10 to the power minus 4. So when you do this subtraction, we finally find out it is approximately equal to the concentration NH2 NH3 plus also is equal to 0.5 into 10 to the power minus 4. So this is how, my dear student, we write it as 0.5 into 10 to the power minus 4, the concentration of NH3, because the concentration of OH minus and NH3 plus are same, and for both of them we can write C alpha as a minus 4, 0.5 into 10 to the power minus 4. So my dear student, we can put these values. For this we write 0.5 into 10 to the power minus 4. The concentration of OH we can write 0.5 into 10 to the power minus 4. But the concentration of NH2 is 0.04 minus 0.5 into 10 to the power minus 4. So by doing this multiplication 0.5 into 0.5, we have 0.25. 10 to the power minus 4, 10 to the power minus 4 is 10 to the power minus 8. And we can have the same value 0.004 minus 0.0005. So you can see that this is the division of 0.00400 minus 0.00005. This is what we can have it, my dear students. So now if we do the required calculations, we will find that 0.25 divided by 10 to the power minus 8 divided by 0.00395. This 0.0395, my dear students, we have obtained by doing this subtraction. So if you do this subtraction here, we will find it. See, this is 5, this is 9, this is 3, these are 0. So we will get 0.00395. So we have this value 0.00395, which is written over here. By doing this, the calculation, this is what for 0.00395 we can write 0.395 into 10 to the power minus 2, and ultimately when this power goes up, it turns to be positive, and finally we get this answer 6.32 into 10 to the power minus 2. So this is what it is, the value for Kb that we get. Now my dear students, we want to study pKb. So pKb is log of minus log of Kb. Our Kb is 6.32 into 10 to the power minus 7, which is minus log of 6.32 plus minus log of 10 to the power minus 7. Log of 10 to the power minus 7, which is minus, gives us the positive value plus 7, and the log of 6.32 is 0.8007, which is simply gives us the value of pKb 6.1993. So this is how, my dear students, we can calculate the Kb as well as pKb. Let us solve one more problem, my dear students. Calculate the pH of the solution which 0.2 molar of NH4Cl and 0.1 molar of NH3 are present. pKb of ammonia solution is 4.75. So you can see that, my dear student, the data given to us is that is what I have written here. This is what we can understand from the question. So our pH we need to find out. We need to find out the concentration of H plus. The concentration of NH4Cl is given 0.2 molar, which in ultimately this NH4Cl, when it dissociates or ionizes, it gives us the NH4 plus, and Cl minus, it ionizes completely, and that is why the concentration of NH4 plus is also equal to the concentration of NH4Cl. The concentration of ammonia is given as 0.1 molar, my dear students, and we are also given the value of pKb. Uh, so pKb is the 4.75. So we can write for pKb minus log of Kb. So we can find out the value of Kb. As we know, pKb is 4.74. Therefore, log of Kb is equal to minus 4.75, which is nothing but minus 5 plus 0.25. Therefore, Kb is equal to antilog of minus 5 plus 0.25. Ultimately, we find out the value of Kb is equal to 1.77 into 10 to the power minus 5, my dear students. Now we have got the value for Kb. So as we move forward, we can calculate the other values. We want to find out the pH and the concentration of H plus. So let us understand how the reaction takes place. We have got the value for Kb, and your Kb value is 1.77 into 10 to the power minus 5. Now, my dear students, when ammonia is added to water, it produces the NH4 plus ion and OH minus ion. The concentration of ammonia is given in the question, which is 0.1 molar. The concentration of NH4 plus ion is also given. So initially we had this concentration. Now we can understand the change. So if we look into the change, my dear students, we would come to know that we have this change is equal to, for reactant, we have the change is minus C alpha. For the product, we have the change is plus C alpha, plus C alpha. So for particular reactant, we can write it as a 0.1 minus C alpha. And for product, we can write, especially for ammonia, we will, NH4 plus and we will write 0.2 plus C alpha. But for OH minus, we can write simply alpha because there was no initial concentration of OH minus available. Now we want to find out the Kb for this equilibrium. So looking into the equilibrium once again, we can write out, the Kb, and our Kb is nothing but the product of the concentration of products. So we will write the concentration of NH4 multiplied by the concentration of OH minus divided by the concentration of NH3. Please remember that while writing Kb, we do not write the concentration of H2O because we are already aware that the equilibrium constant K into the concentration of H2O, that gives us Kb. So when we write Kb, we do not write the concentration of H2O because it is considered to be constant. So for Kb, we can write the value 1.77 into 10 to the power minus 5. We can put these values of the concentration from these equations. So for NH4 plus, we will write 0.2 plus C alpha. For OH minus, we write C alpha. And for concentration of NH3, we write 0.1 minus C alpha. As Kb is the order of 10 to the power minus 5, and that is why we can say that 0.1 minus C alpha is approximately is equal to C alpha 0.1, because 10 to the power minus 5 will give us a very small value. Same way it is 0.2 and this is C alpha. C alpha is very small, and for 0.2 plus C alpha also we can approximately write 0.2. So for 0.2 plus C alpha we will write 0.2. For 0.1 minus C alpha we will write 0.1. So you can see, my dear students, that I have written here that 1.77 into 10 to the power minus 5 is equal to 0.2 multiplied by C alpha divided by 0.1. So by doing this required calculation, my dear students, see this 0.2 divided by 0.1 is equal to 2, and that is what we divided. This 2 is, if we take, if we multiply both the sides with 1 by 2, we will get 1.77 into 10 to the power minus 5 divided by 2 is your C alpha, and therefore your C alpha is equal to 0.885 into 10 to the power minus 5. And therefore, we know that the concentration of OH minus is C alpha, and that is why the OH minus concentration is equal to 8 into 85, 8.85 into 10 to the power minus 6. We are well aware that our pKw, OH minus multiplied by H plus concentration is your Kw, and the value of Kw is 10 to the power minus 14. It's a mistake, I have written pKw, actually it is Kw, and the value of Kw is equal to 10 to the power minus 14, and therefore the concentration of H plus, my dear student, is equal to the 10 to the power minus 14 divided by the concentration of OH minus. So we know that the OH minus concentration is 8.85 into 10 to the power minus 6. So by doing all this calculation, we can find out the concentration of H plus as 1.129 into 10 to the power minus 9. Now, my dear students, we will find out the pH value. We know that pH is equal to minus log of H plus. So by putting the concentration of H plus, we find out that the value of pH is equal to 8.95. So this is how, my dear students, we solve the various problems which are related to the Kb. In the next period, my dear students, we will study about the relation between the Ka and Kb, that we will study into the next. Dear students, if you have any doubt, you can ask me now. If something you could not understand, you can ask me.